ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಕೇಳಿಸ್ತಾ ಇದೆನಾ? ಹಲೋ,
ಎಸ್ ಸರ್, ಕೇಳಿಸ್ತಾ ಇದೆ.
ಸ್ಕ್ರೀನ್ ಕಾಣಿಸ್ತಾ ಇದೆಯಪ್ಪ?
ಎಸ್ ಸರ್.
Okay. So, in the yesterday's class we have derived expressions for the capillary rise and capillary fall. So those expressions are nothing but H is equal to 4 sigma cos theta divided by d rho g. So this expression we have derived for capillary rise as well as for capillary fall. Capillary rise will be in terms of positive value, whereas capillary fall will be negative value of H. Okay, but the expression almost remains same. So for both the things, here for the theta value for the mercury at a glass tube is taken as 128 degree as a standard. Now you just note down one problem. So there is a glass tube of 2 millimeter diameter. This is 2 millimeter diameter glass tube which is immersed in the water. Determine the capillary effect in millimeter if surface tension of the water is 0.073 Newton meter and contact angle is 0 degrees. So for water and clean glass tube, the angle of contact is 0 degree. If the same tube is now immersed in the mercury with a specific gravity of 13.6, which is not having any units, surface tension 0.52 Newton meter, and the contact angle between glass and mercury is 130 degree, find the capillary effect in the tube. So this is what they have given as the problem. So there is a glass tube. First case there is a glass tube and water. In the second case there is a mercury and the glass tube. There are two problems. Okay, now you see that I have to write all the given data into the appropriate SI units. Diameter they have given as 2 millimeter, which is nothing but 2 into 10 to the power of minus 3 meter. Glass tube diameter is 2 into 10 to the power of minus 3 meter. Because it is in millimeter, I have to convert it into the standard SI unit, meter. Therefore I have multiplied with 10 to the power of minus 3 meter. Sigma of water. What do you mean by sigma? Sigma is nothing but surface tension. Okay, so 0.073 Newton meter is the surface tension for water. S of mercury, so that is nothing but they have given specific gravity of the mercury 13.6. It doesn't have any units, therefore it is the standard. Theta of water is 0 degrees and sigma mercury, that is surface tension of the mercury, is 0.52 Newton meter. Okay, it is also given in the problem. And theta for mercury is 130 degree they have given. So unless otherwise they mention, I have to take 128 degrees for the theta. Since it is mentioned in this problem as 130 degree, I have to take the value of 130 degree. That is the contact angle of the mercury. What I have to find out here? He is asking the capillary effect. So capillary effect means either capillary rise or capillary fall. He is not telling in detail. He is not giving any hints here whether it is a rise or fall. He is telling capillary effect. Capillary effect means it may be capillary rise or capillary fall. That we have to find out. That is H value for both the cases I have to find out. Now the first case I will take capillary effect when the tube is immersed in the water. Okay, so when the tube is immersed in the water, what happens generally? The fluid rises like this. So this is the fluid. Okay. Now you see that this is capillary rise. Okay. Now I have to calculate what is the capillary effect. Capillary effect will be capillary rise generally, but don't come to the conclusion whether it is rise or fall. You just calculate it. If you get a positive value, then it will be capillary rise. If you get a negative value, then it will be capillary fall. Now, what is the equation we have learned? H is equal to 4 sigma cos theta, okay, divided by rho GD. So this is equation, or rho dg rho. Okay, so that's what they have written here. That is the same equation. Now you can see 4 sigma instead of writing sigma, he has written as sigma water to be very specific, and cos theta water he has written, and rho water G and D. Since here in this problem there are two fluids, I have to mention the particularly which fluid I am using. Okay. Now H is equal to 4 sigma water into cos theta water divided by rho water into G into D. G and D are same, acceleration due to gravity and diameter. Now 4 sigma cos theta water, so numerator I will keep it as it is. Rho water into G multiplied by G. Rho G is equal to what? Specific weight. Okay. Gamma is equal to rho into G. Density into acceleration due to gravity is nothing but weight density or specific weight. Okay. So these two terms are replaced by this term, that is gamma of water. Okay. So gamma of water is nothing but 1000 into 9.81, that is 9810. And substitute all the values for as it is. Sigma water, that is surface tension of the water, 0.073. Cos theta of water as cos 0 divided by gamma water. Gamma water is nothing but rho into G, that is 1000 into 9.81, that is 9810, multiplied by diameter 2 into 10 to the power of minus 3. 2 millimeter, that is nothing but 2 into 10 to the power of minus 3 meter. So after substituting all these values, we got the answer 0.01488 meter. Okay. Generally, we express capillary rise or fall in terms of millimeter because it is a very small value. Therefore, I will convert it into millimeter. So in order to convert it into millimeter, you have to multiply with 1000. Meter to millimeter, multiply with 1000. Millimeter to millimeter, millimeter to meter, multiply with 10 to the power of minus 3 or divide it by 1000. Now you got a positive value of the H. So this positive sign indicates that it is a capillary rise. So this is the answer. This is the capillary effect for the water and the glass tube. Similarly, do another calculation. Okay. Now the same equation 4 sigma cos theta divided by rho GD, whereas sigma value, density value and theta value for the mercury I have to use. Now again 4 sigma cos theta, rho mercury into G mercury will become gamma mercury, that is specific weight or density of the mercury. Substituting these values, rho 4 is as it is, sigma mercury, that is surface tension of the mercury 0.052 given in the problem, cos theta, cos 130 degrees divided by S mercury. See here again he has changed gamma mercury as S mercury into gamma water. How this equation has come? We know that S is equal to what? specific gravity is nothing but it is gamma of the given fluid or sample fluid divided by gamma of the standard fluid, right? So here water is taken as the standard fluid, therefore S of the mercury will become gamma of the given fluid, that is mercury divided by gamma of the standard fluid 9810. So here this value they have given as 13.6. Therefore rearranging this equation, gamma mercury will become 13.6 into 9810. Okay, so if you do this calculation, now you see that this 13.6 into 9810 will be what? So it will be nothing but it is gamma mercury. So that's what gamma mercury I have written here, that is 13.6 specific gravity of the mercury multiplied by weight density of the standard fluid 9810 into diameter 2 into 10 to the power of minus 3, which is equal to minus 0.00501 meter. Okay, now you see that this is a negative value. Negative sign indicates the capillary depression or capillary fall. General practice to express in terms of millimeter, multiply this one with 1000, then we will get H is equal to minus 5.01 millimeter. So this is the capillary effect in terms of capillary fall or capillary depression is another word is used. Capillary fall or capillary depression. Okay, so this completes the capillary effect calculation for both water and glass tube, and second case mercury and glass tube. So with this, the one example what I have done for capillary rise and capillary fall. So this example is a sample problem. Based on this type of calculations, you will have another some more unsolved examples which I will give you in the assignment that you have to solve. Okay, next one, next problem. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೂ? All are there? Hello, ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೂ?
Yes, sir.
ಓಕೆ,
Yes, sir.
ಕ್ಲೀನ್ ಆಗಿ ಕೇಳಿಸ್ತತಾ ಮಾಡೋದು?
ಹಾ ಸರ್ ಕೇಳಿಸ್ತದೆ
Yes, sir. ಕೇಳಿಸುತ್ತೆ.
ಸ್ಲೈಡ್ ಕ್ಲಿಯರ್ ಐತಾ?
ಹಾ ಸರ್ ಇದೆ
ಓಕೆ,
Yes, sir.
ಏನಾದ್ರು ಇದ್ರೆ ನೀವೇ ಹೇಳ್ಬಿಡ್ರಿ, ಮತ್ ಕೇಳಿಸ್ಲಿಲ್ಲ ಕಾಣಿಸ್ಲಿಲ್ಲ ಅಂದ್ರೆ. ಓಕೆ,
ಓಕೆ ಸರ್
Okay.
ಓಕೆ
ನೆಕ್ಸ್ಟ್ ಒಂದ್ ಪೇಪರ್ ಪೆನ್ ಇಟ್ಕೊಂಡು ನೀವು ಸಾಲ್ವ್ ಮಾಡ್ಕೋಬೇಕು, ಬರೀ ಕೇಳಿದ್ರೆ ಆಗಲ್ಲ. ಒಂದ್ ಪೇಪರ್ ಪೆನ್ ಇಟ್ಕೊಂಡು ನೀವು ಜೊತೆಗೆ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇರ್ಬೇಕು, ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಪೇಪರ್ ಪೆನ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಒನ್. ನೌ ಯು ಸಿ ದಟ್ I'll solve one more problem. Here, this problem is related to the viscosity. Okay, what is the problem? A cubical block of sides 1 meter, andre cube, one cube. You have studied what is the cube in the elements of, sorry, in the first year engineering drawing. Cube means it is a prism which has 6 identical faces, all the faces are square, of 1 meter sides, all the sides are 1 meter, weighs 350 Newton. So I don't know of which material it is made, but it is weighing 350 Newton. Slides down on inclined plane with a uniform velocity of 1.5 meter per second. So there is a inclined plane. On this inclined plane, a cube is kept like this. Okay, so it slides down with what velocity? 1.5 meter per second velocity. The inclined plane is laid on a slope of 5 vertical to 12 horizontal. So it is 5 vertical and 12 horizontal slope they have given. This is the slope. Okay. And has an oil film of 1 millimeter thickness. So between this slope and the bottom surface of the cube, there is a oil film of thickness. How much? So this is 1 millimeter thickness oil is there. So on that oil film, it is going to slide. So with what velocity? 1.5 meter per second. Calculate the dynamic viscosity of the oil. So this is the problem they have given. Now I'll write the data what he has given. I'll take B is equal to 1 meter. B andre, so I have taken that is the side of the cube. So all the sides of the cube are same. So that is taken as 1 meter, and I will take the notation as 1 meter, which is equal to B. Capital W 350 Newton, that is the weight of the cube. Okay, either you can take capital W or small w. So 350 Newton. Newton indicates the weight. So weight of the cube is 350. That is a standard unit they have given. U is equal to 1.5 meter per second. So velocity is 1.5 meter per second. The cube is sliding with the 1.5 meter per second of velocity. Slope is equal to 5 vertical to 12 horizontal. Okay, slope is 5 vertical and 12 horizontal. Theta you need to calculate. Okay, so he has given like this. Okay, slope. So 5 vertical and 12 horizontal. So this is the theta. So how to calculate theta in this way? Here it is sine. Sorry, tan. Tan theta is equal to 5 by 12. So what do you mean by tan theta? Which is nothing but it is opposite side by adjacent side. Correct? Now this is 5 is opposite, 12 is adjacent. So 5 by 12 will be tan theta. Sin theta will be 5 by this one. Okay, hypotenuse. Cos theta will be 12 by this one. Okay, that is adjacent by hypotenuse is cos theta. Opposite by hypotenuse is sin theta. Okay, now 5 by 12 is opposite by adjacent. Okay, so that value is 22.62 degrees that we will calculate here. Coming to the oil thickness, thickness is equal to 1.0 millimeter, which is equal to 1 into 10 to the power of minus 3 meter. Oil film thickness, okay, is 1 millimeter. That I have to convert it into standard unit. 1 into 10 to the power of minus 3 meter. Now what I have to calculate? We have to calculate dynamic viscosity of the oil. That is mu value I have to calculate. Mu value will be Newton second per meter square. Correct? You need to let me check. Yes, Newton second per meter square. New value I have to calculate. So before going to this one, so I have calculated tan theta 5 by 12. So as per this equation, okay. ಯಾರು ಮೈಕ್ ಆಫ್ ಮಾಡ್ರಪ್ಪ ಹರ್ಷ mic off ಮಾಡು 5 by 12. Now you see that theta is equal to tan inverse of 0.4166. That is theta is equal to 22.62 degrees. Okay, I have calculated. See, again there is a figure. So detailed figure in 3-dimensional they have given. 5 is vertical, 12 is horizontal. Okay, weight acts vertically in a downward direction. Okay, weight perpendicular to the face of the slope will be W cos theta. Weight along the direction of the slope will W sin theta. This is the contact area which is having 1 millimeter of gap. Okay, now the component of weight W acting along the plate is equal to the shear force on the bottom of the surface of the tube. Okay, so illi I have to calculate the shear force. So shear force acts in this direction. W sin theta ಇದೆಲ್ಲ ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ. Therefore shear force F is equal to W sin theta. ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೇ ಯಾಕೆ ಆಕ್ಟ್ ಆಗ್ತದೆ ಅಂದ್ರೆ, so the slope is on the slope, the cube is sliding. Therefore in the direction of the movement of the cube I have to take the force. When you take the force in the direction of movement of the cube, then W will be weight acting in a vertically downward direction, and W sin theta will be the weight acting in the direction of the motion or along the slope. Therefore shear force is F is equal to W sin theta. I have to consider. Now you see that W is given, that is 350. Okay, and sin theta. Okay, why it is sin theta? Here on this side it is cos theta. Here on this side it will be sin theta. Therefore sin 22.62 degrees. Okay, it's the sin theta yak bantu anta nodkolri illi W by 12. So ಇಲ್ಲಿ ನೋಡ್ರಿ W by 5/12 ಇದು ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಬರೋದು tan theta. Okay, so tan theta calculation ಬರುತ್ತೆ. 5/12 is tan theta. So after that theta 22.5 degrees I have calculated. So now here illi theta adre you just take, this is a perpendicular to this inclined surface and this is a perpendicular to this horizontal surface. So between this one the angle will be theta, which is similar to this 12 ಗೆ perpendicular W. Okay, so this hypotenuse ಗೆ perpendicular W cos theta. So ಇವೆರಡರ ನಡುವಿನ angle theta ಆದ್ರೆ ಇಲ್ಲಿ ಇವೆರಡು in between angle theta ಆಗುತ್ತೆ. So ಇದು theta ಆದ್ರೆ this force will be W cos theta acting perpendicular to the inclined surface, and complement of that one will be W sin theta, that is acting along the surface. Okay, therefore along the surface now shear force ಕಂಡುಹಿಡಿಯುವಾಗ I have to use F is equal to W sin theta. Now W value is given 350. Sin theta I have calculated 22.62. After that F value I will get 134.61 Newton. So now using this equation, you just see that what equation I have used to calculate the dynamic viscosity. Newton's law of viscosity anta now study ಮಾಡಿದೀವಿ. Tau is proportional to the du by dy. ಇದು ಕಂಡುಹಿಡಿದಿದ್ವಿ. ಸೊ ಇದು ಓದಿದೀವಿ, ನಾವು ಕಂಡುಹಿಡಿದಿಲ್ಲ, ಓದಿದೀವಿ. So now tau is equal to mu into du by dy, where mu is a proportionality constant. So this is Newton's law of viscosity we have studied. The equation na use ಮಾಡ್ತೀವಿ. Tau is equal to mu into du by dy. Mu ಅಂದ್ರೆ dynamic viscosity, du by dy ಅಂದ್ರೆ u by t. du ಅಂದ್ರೆ change in the velocity ಅಥವಾ velocity that we have taken as u. dy ಅಂದ್ರೆ thickness of the oil film, that is t. Okay, so tau is nothing but force by area. So ಇದು ಎಲ್ಲ equation na simplify ಮಾಡ್ತೀವಿ. So what we will do now, so this entire equation we will simplify. How? Now I will consider, you see, F by A is equal to mu into u by t. So ಇಲ್ಲಿ ಬರಿತೀನಿ ನೋಡ್ರಿ, F by A is equal to mu into u by t ಅಂತ ಬರಿತೀನಿ. Right? F by A ಅಂದ್ರೆ ಏನು? shear force. mu into u by t ಅಂದ್ರೆ mu into du by dy. ಈ equation rearrange ಮಾಡ್ತೀನಿ. mu is equal to F by A ಇಲ್ಲಿದೆ into u by t. If you send it on this side, then it will become t by u. Correct ಇದೆನಾ? ಅರ್ಥ ಆಗ್ತಾ ಇದೆನಾ? Okay. Now F ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? ಕೊಟ್ಟಿಲ್ಲ, ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೀವಿ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ 134.61, that is F value. Next area, ಅವನು ಯಾವ ಏರಿಯಾ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು, ಇದು ಯಾವ್ದು ಕ್ಯೂಬ್ ಇನ್ ದ ಬಾಟಮ್ ಸರ್ಫೇಸ್ ಇರುತ್ತಲ್ಲ which is in contact with the oil or this slope, that area I have to consider. ಈ ಕ್ಯೂಬ್ ಏರಿಯಾ ಎಷ್ಟು, 1 into 1 ಎಲ್ಲದು ಸ್ಕ್ವೇರ್, 1 is nothing but the side length 1 meter, so therefore area ಏನಾಗುತ್ತೆ 1 into 1 into T by U, thickness ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾನೆ 1 millimeter, ಅದಕ್ಕೆ 1 into 10 to the power of -3 ಮಾಡ್ತೀವಿ, ಅದು ಮೀಟರ್ ಕನ್ವರ್ಟ್ ಮಾಡಕ್ಕೆ, ಡಿವೈಡೆಡ್ ಬೈ U ಏನ್ ಕೊಟ್ಟಿದ್ದಾನೆ 1.5 meter per second ಕೊಟ್ಟಿದ್ದಾನೆ, therefore it will become 1 into 10 to the power of -3 divided by 1.5. ಇದಿಷ್ಟು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ನಮಗೆ ಏನ್ ಬರುತ್ತೆ, mu is equal to 0.08974 Newton second per meter square will be the density value we will get. This is what I got. It is a, sorry, not density, it is a dynamic viscosity. Okay, dynamic viscosity of the given fluid or oil will be 0.08974 Newton second per meter square. Always you have to write the appropriate units and mention in a box or bold letters, okay, the answer in your final exam. Otherwise you are going to lose the marks if you leave the units. If you leave the units, at least 1 or 2 marks in each problem, you are going to lose the marks. Is it clear? Okay, so in the same way we will study, we will have one more problem, okay, on the surface tension. Now I'll quickly read out because only 10 minutes is left. If the surface tension at air water interface is 0.0 Newton meter, what is the pressure difference between inside and outside of an air bubble of diameter 0.01 millimeter? Okay, so this is what they have given. ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇಫ್ ದ ಸರ್ಫೇಸ್ ಟೆನ್ಷನ್ ಆಫ್ ಏರ್ ವಾಟರ್ ಇಂಟರ್ಫೇಸ್, ಏರ್ ಇದೆ ಮತ್ತೆ ವಾಟರ್ ಇದೆ, ಎರಡರ ನಡುವಿನ ಇಂಟರ್ಫೇಸ್ ಹ್ಯಾವಿಂಗ್ ಎ ಸರ್ಫೇಸ್ ಟೆನ್ಷನ್ 0.07 Newton meter. What is the pressure difference between inside and outside of an air bubble of diameter 0.01 millimeter? Okay, so now what is the pressure difference? So pressure difference I have to calculate. So what will be the pressure between the inside and outside of the air bubble anta keltane. So there is a air bubble in inside pressure ಎಷ್ಟಿದೆ, outside pressure ಎಷ್ಟಿದೆ, ಎರಡರದ್ದು difference ಎಷ್ಟಿದೆ, pressure difference between inside and outside of an air bubble of diameter 0.01 millimeter. Now see that sigma is equal to 0.07 Newton meter. This is given in the problem. Diameter is also given, it is diameter is equal to 0.01 millimeter into 0.01 into 10 to the power of -3 meter. ಇದ್ಯಾಕೆ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ ಮಿಲಿಮೀಟರ್ ನ ಮೀಟರ್ ಕನ್ವರ್ಟ್ ಮಾಡಕ್ಕೆ. ಡಯಾಮೀಟರ್ ಆಫ್ ದ ಏರ್ ಬಬಲ್ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋದು, ಏರ್ ಬಬಲ್ ಕೊಟ್ಟಿರೋದು. ಬಬಲ್ ಅಂದ್ರೆ ಒಂದು ಹಾಲೋ ಸ್ಪಿಯರ್. ಸೊ ಇದಕ್ಕೆ ಎರಡು ಸರ್ಫೇಸ್ ಇರುತ್ತೆ, ಒಂದು ಔಟರ್ ಸರ್ಫೇಸ್, ಇನ್ನೊಂದು ಇನ್ನರ್ ಸರ್ಫೇಸ್, ರೈಟ್? Now pressure difference I have to calculate. We have already studied the equation or derived the equation. Pressure is equal to 8 sigma by D for the hollow bubble. Okay, that is what we have derived the equation while studying the surface tension of a hollow bubble. P is equal to 8 sigma by D. So now P value is what? It is unknown or we have to find out it. So 8 as it is I have substituted, sigma 0.07 they have given, and diameter 0.01 into 10 to the power of -3. So ella values substitute ಮಾಡ್ತೀನಿ. I got the value of 56 into 10 to the power of 3 Newton meter square. Okay, so idu pressure inside the bubble. So what is this? This is pressure inside the bubble, 56 into 10 to the power of 3 Newton meter, ಅಥವಾ 56 kilonewton per meter square. Okay, this is inside the pressure. This is what we call it as a gauge pressure anta karitevi. Outside pressure will be gauge pressure is taken as 0. Okay, absolute pressure ತಗೊಳಲ್ಲ ನಾವು, gauge pressure ಅಂದ್ರೆ gauge ಅಂದ್ರೆ ಯಾವುದೇ ಒಂದು ಮೆಜರಿಂಗ್ ಡಿವೈಸಸ್ ಅಲ್ಲಿ ನೀವು ಅಟ್ಮಾಸ್ಫರಿಕ್ ಪ್ರೆಷರ್ ನ ಮೆಜರ್ ಮಾಡಿದಾಗ ಅದು 0 ತೋರಿಸುತ್ತೆ. 0 ತೋರಿಸಿದ ತಕ್ಷಣ ಅಲ್ಲಿ 0 ಪ್ರೆಷರ್ ಇದೆ ಅಂತ ಅರ್ಥ. ಅಲ್ಲಿ ಅಟ್ಮಾಸ್ಫರಿಕ್ ಪ್ರೆಷರ್ ಯಾವಾಗ್ಲೂ ಗೇಜಸ್ ಅಲ್ಲಿ ಮೆಜರಿಂಗ್ ಡಿವೈಸಸ್ ಅಲ್ಲಿ ಮೆಜರ್ ಮಾಡಿದಾಗ 0 ಇಸ್ ಅ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ವ್ಯಾಲ್ಯೂ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್, ದಟ್ ಈಸ್ ರೆಫರೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ. ಅದನ್ನ ಗೇಜ್ ಪ್ರೆಷರ್ ಅಂತ ಕರಿತೀವಿ. ಗೇಜ್ ಪ್ರೆಷರ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ 0 ಫಾರ್ ದ ಅಟ್ಮಾಸ್ಫರಿಕ್ ಪ್ರೆಷರ್. ಸೊ ಅಲ್ಲಿ 0, ಇಲ್ಲಿ 0 ತಗೊಂತೀವಿ ಗೇಜ್ ಪ್ರೆಷರ್. ಸೊ ಔಟ್ಸೈಡ್ ಇನ್ಸೈಡ್ ಎಷ್ಟಿದೆ 56 ಕಿಲೋ ನ್ಯೂಟನ್ ಪರ್. ಹಲೋ, ಕೇಳಿಸ್ತಾ ಇದೆಯಪ್ಪ? ಹಲೋ,
ಹಾ ಸರ್ ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್.
ಡಿಸ್ಕನೆಕ್ಟ್ ಆಯ್ತದ. ಸೊ ಈಗ ನೋಡ್ರಿ, ಇವೆರಡು 0 ಮತ್ತೆ 56 ಇರೋದ್ರಿಂದ ಇವೆರಡರದ್ದು ಪ್ರೆಷರ್ ಡಿಫರೆನ್ಸ್ ಬಂದ್ಬಿಟ್ಟು 56 ಕಿಲೋ ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ದ ಫೈನಲ್ ಆನ್ಸರ್. ಓಕೆ, so with this I will conclude today's class and I will solve some more class in the next class. So we are already running out of the time, that's why it is disconnecting. So the same video I will try to upload in the YouTube also, and I will share the link. You can go through that one. Okay, is it clear today's class? Any doubts?
ನೋ ಸರ್.
ಕರೆಕ್ಟ್ ಅರ್ಥ ಆಗ್ತಾ ಇದೆ ಮಾಡೋದು?
ಎಸ್ ಸರ್.
Yes, sir.
Yes, sir.
Thank you.